Yo, so basically this is every single equation that you need to know for acid and bases, especially the formulas for it. So immediately, let's just start going down the line. pH, the Ka, Kw, and Kb, buffers, and I'm not gonna look at titrations now because that's just too much. If you've seen the problems there, you're cooked. But titrations, buffers, that's for AP Chem, you don't need to look at that. Chemistry, honors chemistry kids, this is pretty much your part right here. So immediately, pH and the POH. So let's look at the formulas for it. So if you probably don't know, but here's the basically the most of the stuff that you know. pH and POH. Here are the formulas for it. So pH is the measurement of basically the acidity, especially for an acid. So negative log of H plus. So here pH, H plus, POH, OH minus pretty much. But basically pH of the negative log of H plus, acids, if you don't know, give off H plus. This is the hydrogen atom, or it could be H3O plus, which is the hydronium ion. But it could be H plus or H3O plus, mostly H plus, but you know, I just put H plus here because it's simpler. So basically you take the negative log of said concentration of H plus and you just get pH. That's easy, right? So now moving on to POH, same thing. Just take the negative log of the OH concentration and you just get the POH. That's just how you do it. So POH, OH, pH, H plus. Easy way to remember that, right? So now here's when it gets complicated. pH and the POH always equal 14. 14, this value does not change. These two values always will equal to 14. So let's say we calculated pH. So let's say we calculate pH. We say pH is 8. And we get a POH of, and actually let's say we don't know the POH. And we know that it's always equal to 14, right? So pH plus POH equals 14. If we know pH is 8, subtract 8 over. And we know the POH is gonna be 6 this time. Easy enough, right? POH of 6, because we just figured out that pH is 8, so just subtract 8 over, POH is 6. Easy, right? Now, Ka and Kw and Kb. So this is probably something that you guys don't know yet, but here's just a quick overview of it. Ka is going to be the equilibrium sign. If you don't know equilibrium, you can go back a little bit, but Ka and Kb, these two are going to be the equilibrium values of an acid or the equilibrium values of a base. All right, and here are the two, basically the two only equations that you really need to know for it. So Kw equals to the Ka value times the Kb value. Ka times Kb equals Kw. Easy to remember, right? And if we know that, and we already know that Kw equals to 1.0 times 10 to the negative 14. This is only at 25 degrees. This is only at 25 degrees, I think it's Celsius, I think it's Celsius, 25 Celsius degrees. 25 degrees Celsius. This is only at this temperature is Kw gonna be 1.0 times 10 to the negative 14, okay? You need to remember that, okay? Because if they give you like 35 Celsius, it is not gonna be Kw. This is not gonna be 1.0 times 10 to the negative 14. It is not gonna be this value if it's 35. And almost always, for these problems, they are gonna give you the K or Kb. So you do not need to memorize the K or Kb of a specific acid or base. They're just gonna give you these values, okay? Or they might ask you to calculate the Ka values. And if you don't know how to do that, it's just gonna be a basic ice table problem. So they're gonna give you a bunch of concentrations, the X values, and it's just gonna be the basic thing. Remember ice tables and ice, remember the what's it called? The equilibrium constant expression. It's just gonna be products over the reactants. That's just how you calculate K. And it could be Ka or Kb, depends on where you're finding, if it's an acid or a base, but they're just gonna give you it. Easy enough. Now, moving on to buffers. These two, really, these are only for AP Chem, so you guys can switch off if you're not part of that, but buffers, all right? So this is where it starts ramping up bad. All right, so good luck to you guys. But buffers are gonna be something where we have an acid and the base, and we're gonna mix them together, right? And it's gonna create a buffer. Basically, a buffer is where something was able to counteract another substance. So let's say we have an acid buffer. Acid buffer. So basically, there's gonna be more H plus in it, right? Because it's gonna be acidic. High pH and lower pH actually because it's acidic. And let's say we add a base into it. So if we have an acid buffer in the base, we know that bases like H pluses. They dig them, you know? They like them. So bases are gonna take up the acid. The acid produces H plus, right? So if the acid produces H plus, the base takes them, it's gonna counter, right? It's gonna counter the base that we just put in. So overall, it's gonna start countering this out. It's gonna start countering until it basically returns, and then basically it's gonna go and it's gonna counteract the base, and it's still gonna be acidic, but basically a tiny bit less acidic because we just added some base into it. So it's always gonna bring up the pOH, but a tiny bit counters that pOH addition, the OH minus addition. So basically, these are the only two formulas you need to know for it. So pH equals to the negative log of the Ka, the equilibrium value of the Ka of the acid, plus the log of the base that we just added over the acid. Alright, so basically the base is gonna be, they're gonna give you the concentration of the base and they're gonna give you the concentration of the acid. So let's say we're getting 0.1 molar of a base and we're putting together another 0.1 molar of an acid. Combine those two, it's basically gonna create a buffer, right? Like we just talked about, it's gonna counter whatever the heck we just put in afterward, okay? So basically, a buffer, so we're gonna make a buffer. If they tell you to make a buffer, immediately use these equations. So we know pH equals to the negative log of the Ka plus the log of the base of concentration that they're gonna tell us over the concentration of the acid. And same thing for this one, but instead it's gonna be Kb and the acid over the base. So basically just flip-flop. So if you want to find pH, put the acid on the bottom. If you want to find pOH, put the base on the bottom, basically. Just flip-flop them. And then we're going to figure out those values, okay? So then we'll figure these, we combine all of this, we figure it out, we calculate. And we're going to figure out the pH of the buffer or the pOH of the buffer, which is basically going to be, whatever they tell us, okay? And then titrations, no. I'm not going to go over that, probably in a later video, but really, it's gonna be so much more complicated than whatever the heck I'm talking about right now. If you can't get it, please look at a different video. But yeah, that's pretty much it. Thank you.